Hello, doctor. My name is BanYuanyuan, and this is a presentation of my project paper. The title of my paper is Investigating the Link Between Economic Growth, Industrialization, and Carbon Emissions in China. Insights from ARDL Model. First, I want to introduce you about my research background. As shown in the figure on the right, China's industrialization level, carbon emissions, and per capita GDP have increased year by year since the 1980s, especially after 2000, when the three showed a more obvious growth trend. And from the left figure, we can see that there is a strong positive correlation between GDP per capita and carbon emissions per capita. As GDP per capita continues to rise, carbon emissions per capita are also increasing. This trend highlights the close connection between economic growth and carbon emission. In this study, I selected three representative indicators, namely carbon emissions per capita, that's CO2, GDP per capita, GDP, and industrialization level, named IND. As the research objects, I found and downloaded data of these indicators from 1984 to 2023 from the World Bank. In order to study the dynamic relationship between economic growth, industrialization, and carbon emissions, especially for a rapidly developing country like China, the relationship between economic growth, industrialization level, and carbon emissions may be different in the short and the long term. So I decided to use the ARDL model to estimate and capture these differences. In order to study the relationship between IND, GDP, and CO2, we constructed an autogressive distributed lag model. The basic form of the model is as follows. Then I will complete the ARDL model estimations in views. First, I conducted a unit root test on these three variables to determine the stationarity. From the test results in the table, we can see that the t-values of the three variables are all greater than the critical values of the three levels, and the p-values are all greater than 0.05. The original hypothesis cannot be rejected, which means that the source data does not pass the PP test. Therefore, these variables need to be further differentiated to test its stationarity. So I conducted a unit root test on the first-order differences of the two variables. From the table, we can see that the t-value is all less than the critical value of the significance levels, and the p-value is 0. So we can reject the hypothesis. To sum up, the three variables are I1 sequences. And then I conducted an ARDL model estimation in views. The table on the left is the results. The results show that there are significant short-term and long-term relationships between the three variables. The R-square value of the model is 0.9989, indicating an extremely high fit, and the F statistic is 2,946.286 with a p-value of 0, proving that the overall regression is significant. The lag term of CO2 has a significant positive effect on the current CO2 value, which coefficient is 0.792037, and the p-value is 0.001, while lag terms 2 and 3 are not significant. The lag term of industrial production level has a significant negative effect on CO2, and the lag terms of GDP shows complex relationship, with lag terms 1 and 3 having a negative effect on CO2, while lag term 2 show a positive relationship, which p-value is 0.0191. And I conducted a bounce configuration test of this ARDL model. From the results of the bounce test, as we can see, is a left table. The value of the F statistic is 8.086797. Is significantly greater than the critical value at all significance levels. So we can reject the null hypothesis, which means that there is a long-term configuration relationship between the variables. And then I conducted a heteroscedasticity test. The table on the left is the results, and we can see that the p-values of the statistic OBS R-squared and the scaled explained SS are all greater than the significance level of 0.05, and the null hypothesis cannot be rejected. It can be seen that there is no heteroscedasticity problem in the model. That is, the variance of the residual is constant. Therefore, according to the ARDL analysis results, the CO2 emission dynamics model is as follows. First, the constant term 1336.354 suggests a base level of CO2 emissions that is influenced by other factors. Secondly, the negative relationship between GDP and CO2 emissions supports the hypothesis that economic growth may be accompanied by reductions in emissions, potentially due to the adoption of greener technologies or a shift toward surface-based economies. And thirdly, the effects of industrial output and past CO2 emissions show some interesting dynamics where the current industrial output and past emissions influence the present CO2 emissions. And then, in order to better capture the interaction between the short-term fluctuations and the long-term relationships and analyze the long-term equilibrium path between variables and their short-term adjustment process, this study constructed an error correction model. These statistical results are as follows. Based on the output of the model, the following error correction model formula can be obtained as follows. First, sustained impact. CO2 emissions in the previous period have a significant positive impact on the current period, indicating that emissions have a certain degree of sustainability. And GDP suppression. GDP growth in the previous period has a negative impact on CO2 emissions in the current period, which coefficient is minus 0.859, indicating that economic growth may reduce emissions through technological progress or structural transformation. And the slow equilibrium adjustment. The coefficient of the error correction term is small, which is 0.0438, indicating that the model adjusts slowly to deviations from long-term equilibrium, and the system takes a long time to return to equilibrium. And this is a policy implication. First, about the policy implication is promote green technology and low carbon economic transformation. The model shows that economic growth is negatively correlated with CO2 emissions. So China should increase investment in green technology, clean energy, and low carbon technology, promote the transformation of the economic structure to low carbon, sustainable, service-oriented economy, and optimize the energy structure to achieve green growth. Secondly, strengthen the industrial low carbon transformation and historical emission management. Industrial output and historical emissions have a significant impact on current CO2 emissions. China should promote low carbon transformation in high pollution and high energy consuming industries, encourage green technology innovation, gradually eliminate high pollution production processes, and strengthen the management of historical emissions to reduce the impact on existing emission levels. A third is pay attention to long-term sustainability and policy adjustments. The continued impact of CO2 emissions shows that it is very important to set long-term and operational emission reduction targets. China needs to strengthen policy consistency and stability, promote economic structural adjustment and green technology application, and adopt a gradual policy adjustment approach to avoid excessive reforms that cause social and economic instability. And this is a policy implication. That's all. This is my presentation. Thank you for listening. Bye bye.